Hello. In this video, we are going to learn one of the most basic terminology in financial mathematics, annuity. You need to understand this concept to account for certain transactions such as loan amortization and long-term saving plan. The annuity concept is widely used in personal financial planning. For example, you can use the concept to estimate the amount you need to save consistently in order to accumulate a given amount at a future date. This video will provide the tools to calculate annuity using Excel. Let's start. An annuity is a series of equal periodic cash flow over a specified time period. Examples of annuity include loan with fixed and periodic payments, fixed monthly income, pension plans that give retirees a fixed annual income. These cash flows can occur at various intervals, such as annually, semi-annually, quarterly, monthly, weekly, or daily. The cash flow in an annuity can be inflows or outflows. There are two types of annuities, ordinary annuity and annuity due. An ordinary annuity has a first cash flow that occurs one period from now, time equals to 1. The cash flow occurs at the end of each period. The keyword for ordinary annuity is N. An annuity due has a first cash flow that occurs immediately at time equals to 0. The cash flow occurs at the beginning of each period. The keyword for annuity due is beginning. Let's take a look at this example. Annuity A and annuity B both generate cash flow of 1,000 for the next 5 years. Are these two annuities the same? If you are given a choice, which annuity would you choose? Annuity A is an ordinary annuity with cash flow occurs at the end of the year. Annuity B is an annuity due with cash flow occur at the beginning of the year. We shall analyze further. This slide shows the formula to calculate the future value and present value of ordinary annuity and annuity due. Are the formula the same? Do you notice something extra at the formula of annuity due? The formula of annuity due has something extra. The future value and present value are multiplied with 1 plus I. This is because cash flows of annuity due occur at the beginning of the year. Therefore, the future value or present value of annuity due is always larger than ordinary annuity. Here is an alternative way to express the formula of annuity. Sometimes you do come across different ways to express formula in different reading materials. This formula is used to calculate the present value of annuity. C stands for cash flow, R stands for interest rate, and T stands for time. Now I would like to show you how to calculate the future value of annuity using formula. In this example, let's assume interest rate is 5%. There are two types of annuity here, ordinary annuity and annuity due. The cash flows are 1,000 for 5 years. I'm going to type equal 0.1000 multiply open bracket 1 plus interest rate close bracket power of open bracket 5 minus 1 close bracket. The reason I type 5 minus 1 is because the first cash flow occurs at the end of year 1. There are 4 years to earn interest. I'm going to fix the reference cell for interest rate. by typing F4. Enter, and here is the answer. Next, I would drag all the way down to obtain the rest of the answer. Alright, I will total all this cash flow equal SUM open bracket, highlight all the cells, close bracket, and here is the future value of ordinary annuity. Next, I'm going to do for annuity due. I can copy this answer, copy and paste here. Alright, but bear in mind we have to make some adjustment for the year. Alright, point here. Close bracket, that is the answer. Then I drag all the way down. I can also drag this across. Alright, and this is the answer for annuity due. We can also make use of the Excel built-in formula to calculate future value of annuity. This method is much faster. Let me show you. I'm going to type equal future value, open bracket, point the interest rate of 5%, comma, 0.5 for years, comma, 0.1000 for PMT. Take note that I put a negative sign here because I assume the 1000 is a cash outflow. The 1000 is an investment. I'm doing this because later I will get a positive value for future value. Next, type comma. Present value is equals to 0, so I type 0 here. Comma. This is an ordinary annuity with cash flow occurs at the end of the period. Therefore, I should type 0 for ordinary annuity. Close bracket. And here is the answer. The answer is the same as using formula. Next, I would like to do the same for annuity due. I'm going to type equal future value, open bracket, point the interest rate, comma, 0.5 years, comma, 0.1000, put a negative sign for 1000, comma, 0 for present value, comma, and take note that here we should type 1 for annuity due. Close bracket, enter, and this is the answer. To conclude our finding, annuity due always have higher future value and present value than the ordinary annuity. This is because each of its annual cash flows can earn interest for 1 year more. In this slide, I list the Excel function to calculate annuity. The Excel function is PMT. Personally, I think PMT stands for periodic payments. Type 0 refers to ordinary annuity. Type 1 refers to annuity due. Let's look into one more example. If a pension fund of 1 million is required in 20 years, how much do we need to save? We all hope to become a millionaire one day. Let's find out the answer. If interest rate is 5%, calculate the annual pension contribution, monthly pension contribution. Let's do it together using Excel. The cells highlighted in yellow represent the input from the example. First, I would like to calculate the annual pension contribution. I'm going to type equal PMT, open bracket, point the interest rate of 5%, comma, point 20 years, comma, present value is 0. Therefore, I type 0, comma, future value is 1 million. So I point 1 million, comma, I type 0 for ordinary annuity. Close bracket. Here is the answer. The answer is in negative because it represents cash outflow. We need to invest first in order to achieve the future value. Next, I'm going to calculate the monthly pension contribution. Take note that for monthly compounding, we have to divide the interest rate by 12 and increase the time period by multiplying 12. We adjust the time period by multiplying 12 because in 20 years there are 240 months. Let's start. Equal PMT open bracket 0.5% divide 12, comma, point year multiply 12, comma, present value is 0, comma, future value is 1 million, comma, type 0 for ordinary annuity, close bracket, enter. Here is the answer. We need to save about $2,433 in order to achieve 1 million. Finally, we have come to the end of this video. Thank you for watching this video. Please practice the examples given in the Excel spreadsheet as practice makes perfect. I hope to see you again. Bye.